Welcome to our Steidle Café. This semester, we're celebrating 115 years of the Department of Material Science and Engineering at Penn State. And then last year was the 125th anniversary of our College of Earth and Mineral Sciences here at Penn State. And so in celebration of these two milestones, we have a number of alumni who have been named 125th anniversary fellows of our college that will be joining us during our Steidle Café. So today we have Dr. Erica Redline and Melissa Marshall. We'll start off with Dr. Redline. She is a principal member of the technical staff in the Organic Material Science Department at Sandia National Laboratories. She received her BS in Material Science and Engineering from Penn State and her Ph.D. in Material Science at the University of Minnesota. And her work at Sandia focuses on polymer science and ranges from developing next generation encapsulation technologies to study polymer degradation in extreme environments to resolve polymer processing issues for various injection molded parts. So welcome, Dr. Redline, the floor is yours.
Great, thank you so much for the introduction. Thanks everybody for joining. So I figured I would start where I started, which is in the coal region of northeastern Pennsylvania. So I grew up in a small town called Jim Thorpe, so named after the athlete that is buried there. And I graduated there in 2002. It's pretty, like I said, it's a small town. There's about 5,000 people there. So you kind of know everybody who you graduate with, and it's kind of changed when you go to Penn State and you don't know everybody. There's a lot more people. But I just wanted to highlight some pictures from the town. So this is downtown Jim Thorpe looking up Broadway. You can see the courthouse, the Packer mansions, and this is taken in fall. It's a really beautiful time of year so that the town actually kind of sits in the valley of the Appalachians and you can see all the colors around you, which I really loved. The train station is a big part of the town. It's kind of why it grew when it did for the coal mining. I'll talk about that in a second. And then one of the Packer mansions, this is actually a bed and breakfast that you can stay at. But Asa Packer actually lived in the town, and he is known because he founded Lehigh University. And so he started out by building canal boats to take the coal from the mines in the mountains here and move them to other parts of the state, and eventually invested in a railroad to move that coal. And so that's how he got his fortune. And I quick want to shout out Bernie Krebs, who is the photographer who took all these wonderful photos and let me share them today. So thanks, Bernie, for letting me do that. So in 2002, I started at Penn State. And I was a bio pre-med major, and I was convinced I was going to be a surgeon. I thought I was going to be a cardiologist. I don't know. I thought I was going to be a medical doctor. But I quickly realized that I didn't like biology. I thought it was kind of boring and too much memorization, and I really liked chemistry. And I was also fortunate living in the dorms. I was in Tenor Hall on the very tip-top floor, the 10th floor, which didn't have air conditioning, so it was miserable when it was hot. But the guy on the floor directly below me, Kurt Chang, he was in material science, and he was telling me about it. And I was like, oh, that sounds interesting. So I took the intro class that Professor Randall gave, and I liked it. And I also figured out at that time that I liked organic chemistry. So it seemed natural that I would concentrate in polymers. And so one of the first courses you take in polymers was, Intro to Polymers, taught by Professor Painter. And if you've ever had the opportunity to take a class from him, he's a character, and he really makes polymer science fun. So he really kind of got me hooked on polymer science, and he allowed me to work in his lab. And so Professor Painter, if you're ever watching this, I still do infrared spectroscopy, and I actually have 2 of those spectrometers in my lab now. So I still do that regularly. And I'd like to think that I got the start from you. He also is the one who encouraged me to do a research experience for undergraduates. And when I got accepted to 2 programs, I couldn't decide where to go. He's the one that suggested I go to Minnesota and try it out there. I'd never been to a really big city like that before, or that far west before. So he's like, just go for it, go to Minnesota. They have a great polymer program. So I did. The next influence is not coming up straight. Professor Manias, who was my senior thesis advisor. So all the matse students, we had to do a senior thesis, and I worked very closely with Matt Heidecker. And so I worked on polymer composites, working with making blends of polymers with clays. And I worked very closely with Matt for that. And he was great because he let me, from start to finish, see a research project, right? You're going to make the polymers, you're going to extrude it, you're going to cut the extrudate by hand, which is terrible. And I don't know if I told my DuPont colleagues that at some point, but there's actually choppers that you can get for them. But we would cut them by hand. We cut the polymers by hand with scissors. and then do all the characterization. So Matt was really great about letting me do all of that, get my hands on everything, and kind of showed me what it's like to kind of the satisfaction that you get from doing a research project. And I randomly ran into him at an airport a few years ago, which was kind of fun. And the last person is Professor Kimmel, and I saw you're on, so I'm glad you are. I think the polymer science lab that you did and all just the introductory labs really helped me find my love for polymer science, find my love for material science. And also really importantly, remember one summer you asked me if I'd be a camp counselor for the summer materials science camp. And that's what I guess has driven my lifelong desire to do outreach to get students interested in STEM. So I got to stay in the dorms with the students. I got to take them to the different activities they were going to do. I got to participate in, and I got to see like that spark in their eyes when they got really excited about it. And so because of that, outreach and mentoring is a really big part of what I'm doing now. So thank you for that. So the other influences at Penn State that I had were some of the organizations I was a part of. So I was an EMT, part of the Emergency Medical Services Association. You can take a class at Penn State, you can get certified, you can join the Penn State Ambulance Company, Company 20, like I did, and it was a blast. So here's a group picture of us. There's me sitting on Beaver Field for one of our group photos. Here I am, at a training, and these are the ambulances that I drove. We started out with 2051 in the background, and then we've eventually got 2050, and I don't know what the ambulances are now, but it was fun driving those around. The other one is Levy, the Penn State Yearbook. So I did that for all 4 years. I started out in the student life section. I became the editor of that section the next year, and then I was an editor for the next 2 years. So here I am in that blurry picture in the front row as one of the editors of Levy. And so that was a nice little creative outlet for me that I really enjoyed doing. So after I graduated from Penn State, I didn't really know what I wanted to do. And I remember Professor Manias and I were standing outside of the front of Steidle, and I was like, I don't know what to do. I don't think I'm ready to get a job. And he was like, just go to grad school. It's free. They'll pay you to go. So I was like, all right, that sounds like a good idea. So I applied to a bunch of places, and I ended up going to Minnesota because I'd been there before. I really enjoyed it. And in Minnesota, there's a lot of co-advising that happens. So I was advised by Lorraine Francis, who's shown here in the yellow shirt. I'm sitting in the back there. Let's see, I've got to move that's me there. And then Frank Bates. And so luckily for me, they had two very different advising styles, which I think was really beneficial. They also had two different skill sets. And so I think having the interplay of the two advisors really helped develop me into the researcher that I am today. Unfortunately, I couldn't find a picture of Frank's group from when I was there, but nevertheless, I was there and I worked on structure property relationships. So I think my senior thesis work at Penn State made me realize that I really enjoyed that type of work. And so my thesis there was using block copolymers to toughen thermosets. And so after I graduated there with my PhD, I decided I was going to go to DuPont. And so let's see, so let me switch. So I went to Wilmington, Delaware at the experimental station, where I was in the polymer engineering group for a couple of years. And again, I think you're seeing a theme, right? There's always people that have influenced me no matter where I have gone. And first being Mark Wetzel, who was there when I started, and Marios Avgusti, who taught me all I needed to know about extruders, scaling up processes, how influential screw design is, which I didn't have an appreciation before. Mark's actually retired now, and he was a fellow when I was there. Heidi Birch, she's another DuPont fellow. She's still at DuPont. And actually I had the experience of working with her again. She was my industrial mentor for a program that the Department of Energy does called the Energy I-Corps, which tries to pair Sandia researchers with industry and get our technologies out there into the world that you spent all your tax dollars on developing these technologies. You actually want to use them. So 2 years there, I decided I didn't really like the extrusion work. I wanted to do some more, I guess, materials development, some more hands-on work. So I applied for a job at Sandia, and I kind of wanted to go into the mountains anyway. My husband's a big skier and got me into skiing, so wanted to be closer to that. You can see I'm still doing outreach. So Professor Kimmel, I promised you I'm still doing it. I am. This was before COVID. I was doing a career day for, I think it was a local elementary school, and more recently at the Society of Women Engineers local meeting that was held in Albuquerque last month. So I was recruiting some excellent female talent to Sandia Labs. So I'm hoping I'll see some of those faces soon. So we have a really great recruiting team. And then I got asked to talk about some work that I'm excited about. And so I thought I would talk about kind of my little bread and butter right now, which is polymers that have low coefficients of thermal expansion. So what do I mean by coefficient of thermal expansion? It's just a property that all materials have where it measures their rate of change of one dimension as a function of temperature. So all materials, or most materials, when you heat them, they expand, and when you cool them, they contract. So just like this diagram shows, heat it, gets bigger, cool it, it goes back down. Depending on what type of material you have, it will expand and contract at different rates. So here's just an example. On the left, in this orange box, we'll assume it's something like a ceramic, and on the right, a polymer. So a polymer has a higher coefficient of thermal expansion, or CTE, than a ceramic. So if I heat it, it's going to expand more than the ceramic. Likewise, if I cool it, it's going to contract more than the ceramic. Now, the issue becomes when you have these different types of materials in intimate contact with one another, these expansion differences, or this thermal expansion mismatch, can cause issues. So things like cracking or warpage or even delamination. And it turns out that a lot of applications aren't just single materials, right? A lot of applications have many different materials in contact. So electronics, like I showed on the last slide, your printed circuit boards, those boards are made from epoxies with composites, renewable energy. I don't know what happened there. Just got like a weird glitch on my slide. So your solar panels are made up of a lot of different materials. Automotive industry, you've got lots of different composites there, as well as marine and aerospace. So the typical way that we deal with this thermal expansion mismatch issue is we'll put in fillers. So if we have a polymer, that's usually the problem child because it's expanding and contracting a lot more than everything else around it. So we'll put in fillers, some type of ceramic or something that has a lower CTE value. But there's limitations with that. There's only so much filler you can put in. It makes processing more difficult, and it can change the properties of the material in ways that you might not want. We had this idea to be able to tune the coefficient of thermal expansion by using the molecular chemistry of the polymer. So luckily for us, there was a paper that came out in 2018 that really inspired this work. And they showed that there was this, this molecule, this dibenzocyclooctane, that it sits in this conformation here at low temperatures. So this is called a twist boat conformation. So I'm representing that by an orange sphere. And so most of the molecules in the structure will be in that conformation. When you heat it up, it goes into this chair conformation. So I like to think it's lounging and it's trying to catch some rays. And so the net effect of that is basically that when you heat it, it will shrink because this chair conformation is a lower volume than the twist boat. So we decided to try to take advantage of that and functionalize it and use it in epoxies. So the way that we measure coefficient of thermal expansion is using a technique called thermomechanical analysis. So I'm basically measuring the percentage change in length as a function of temperature. And these curves here all represent typical epoxies. So I heat it up, the material is expanding like I'd expect. At some point, it's going to hit this inflection here. This is known as the glass transition temperature, and it's a property that all polymers have. So below it, the material is pretty rigid and glassy, and above it, it acts like a rubber. So because it's got more mobility, it's going to expand faster. Our material, however, when you heat it, you can see it's expanding at a much lower rate. And when we get to that glass transition temperature, it actually contracts, and it contracts pretty massively. And so much so you can see that the net change in length is actually negative. So we believe that this is the first demonstration of an unfilled epoxy having negative coefficient of thermal expansion behavior, as well as the first epoxy having such a low value of coefficient of thermal expansion. And we measure that. In this case, we care about that value in the glassy state. So we measure it by the slope of that TMA curve there. You can see those typical epoxies are about 60 parts per million per degree Celsius. We're down at a little bit below 20 here. So it's about a third less. So we're pretty proud of that accomplishment, especially because we didn't do any optimization. We didn't have a lot of material to start with. So we did what we could. And the other cool thing is that this is reversible. So you don't get stuck in this conformation once you heat it up. It actually twists and goes back and forth. So here's again some more TMA data. We're looking here at sample length and temperature. So I'm just cycling the temperature up and down over this range up here. And you can see I heat it, it contracts, I cool it, it expands, and it will keep doing that. And you can actually recover this initial large expansion value just by sitting it at room temperature for a while. So if you thought that was interesting and you want to know more, we do have a paper in ACS Macro Letters last year, so you can check it out there, or you can email me with questions. So I thought I would conclude with some of my favorite Penn State memories. So here is my roommate Crystal and I, we went to high school together. This was after a big snowstorm. We're outside in the parking lot at Tenor Hall. That's Deanna. She became a roommate for a couple of years. She lived right next door to us in the dorms. This is me at graduation with Brad, who was another student. And I guess I liked him a lot because I ended up marrying him. So we're going to be celebrating 10 years this fall, I believe. Yes. Sorry, Mom. I'm not good with dates. This is some of my company 20 girls. So again, there's Crystal. We roomed together all 4 years. Laura and Katie, we had a blast together on the ambulances. Thanks to the EMT work, I got to do a lot of events, especially at Beaver Stadium and at the Bryce Jordan Center. And in particular, I remember seeing Prince at the BJC, and that's probably to this day the best concert I've ever seen in my life. Definitely the football games, when I was working them, it kind of depended on who we were playing and what time we were playing them, how much of the game I got to see. So it was Ohio State at night. I didn't get to see a lot because I was dealing with patients. But nevertheless, that was a really fun experience. Thon, if you haven't done it, is amazing. It's a great organization to be a part of. We did a lot of the medical care there, but I would always go and check it out anyway, because it's just such a wonderful event. And then finally, I was a foster mom for a brief period for Center County Paws. So if you're looking for volunteer opportunities, I'm sure they'd love to have you. If you're looking for a pet, they are a no-kill shelter there in Center County, and I'm sure they would love for you to come adopt an animal like Jake shown here. And finally, just wanted to end saying we are Penn State, and thank all the people that have supported me throughout the years, in particular my family, who are the ones that really encouraged me to go to college and kind of pursue my dreams, and were there when I was trying to figure everything out. My husband, my grandfather, he actually, I graduated on his birth date, so that's kind of special, my Penn State graduation. And then this is my 5-year-old who somehow makes eating mac and cheese look really cool, cooler than I ever could. So with that, I'm going to conclude, and I'm happy to take any questions.
Great, thank you so much. We'll start off by saying, if you have questions, could you please put them in the Q&A or chat, or you can use the raise hand function. So there's a number of ways that you can ask a question through this process. I have a quick question. Well, I have a couple, but first one is, was your friend, the friend you showed, was that Crystal Duffy?
Yeah, she's a pediatrician. I should have said
okay,
that.
Yeah, my kids
State College.
Yeah,
yes,
that's what I thought. She looked familiar. I thought my kids go to see her. So
yep.
That's cool. Okay, so we have a question in chat we can start off with, is not related to research. Have you ever been the Muggles mug in Jim Thorpe?
I have not, and I'm a Harry Potter fan. That happened. That restaurant got there after I graduated. I haven't been back in a while. My family actually just moved from Jim Thorpe to be closer to my brother, so I'm hoping to get back there again soon. I really want to go tour the Asa Packer mansions again. It's been a while since I've done that. So
great. I had a question related to this. So you kind of showed a lot of really interesting outreach that you have done and continue to do. Do you have any advice to our students on the line who are interested in outreach in terms of ways to seek out opportunities or sort of encouragement for them to do this?
Yeah, I guess the best way is to, talk to your professors, see what they're doing. You don't have to go through an official channel. A lot of times local schools will ask for help, maybe for a career day, or they need help with like a robotics team or something like that. So just keep your eyes peeled. It doesn't hurt to email a principal and say, hey, if these opportunities come up, let me know. But I think it's really, really important. It's really important, especially if you're a female, especially if you're an underrepresented population, to do this. It's for kids to see, hey, there's a lady scientist. Hey, there's a scientist that's my skin color. So I really think that should be a priority for everyone.
Great, thank you. Another question came into the chat. Where's your favorite place to ski?
Telluride. I love Telluride. If it wasn't so expensive, I'd be living there.
Great. Another question is, how did you manage your time at Penn State with so many activities?
It wasn't easy. Because I switched majors, I had to catch up courses. So I did take advantage of taking courses from like Lehigh Valley campus. I did some chemistry courses to catch up there. And I did summer courses as well, so I'd have less workload. But if it's important to you, you'll find time for it. So I know that I needed, and maybe not at the time, but now I know I need a creative outlet. So that was what Livy was for me. The EMT thing was out of fun, but also necessity. I needed a job. I needed, I needed to make money, and it was a great way to make money.
Great. And then we'll end with one last one here, which is, with everything that you're doing, how do you keep a work-life balance?
Again, if it's important to you, you will make time for it. Right. My job is my job, and I try to keep those hours of my job to my job hours, and I try to keep the rest of my time to my family and my other hobbies. So you have to just kind of make a priority. I try, like I said, I just keep things on their box. It's like, I'm working on work at this time, and I'm not working at work at this other time. That's family time. And that's okay. You don't have to kill yourself for your job to be successful. You have to find good people to work with. You have to train them well, and you have to treat them right. And when you have a good team working for you, you can do a lot more.
Great. Thank you so much. Well, thank you for your presentation and for all the questions. And so we'll switch gears now and turn to Melissa Marshall. So we have our next speaker is Melissa Marshall. She's the Vice President of Global Internal Audit and Risk for Westinghouse, with accountability for internal audit and enterprise risk management. She's responsible for rebuilding and transforming the internal audit team so that the department is viewed as a strategic business partner. And she has her BS in Material Science and Engineering from Penn State, with honors in Metals Science and Engineering and a minor in Economics. She also has an MBA from Carnegie Mellon's Tepper School of Business and a graduate certificate in Strategic Decision and Risk Management from Stanford University. And finally, she's also a licensed CPA in the state of Pennsylvania. So thank you so much for being with us. The floor is yours.
Thanks, Allison. Good morning, everyone. It's great to be here talking to you. I'm kind of going to spend this time talking about how somebody who majored in material science and engineering ends up the head of internal audit and risk, because it's not a path that you see often. A little bit about myself. I grew up in Natrona Heights. I'm a true Pittsburgh native, born and raised there, and lived there until, I would say, about 2 years ago. Natrona Heights is a true steel town. We still have an actual working steel mill in town. It's Allegheny Technologies. ATI Brackenridge Works has everything from melt shop to hot rolling to the finishing department, and their Natrona Heights operations, which is their R&D center. Growing up, similar to Erica, I loved math and science, particularly chemistry. Thought I wanted to be a chemical engineer until I realized that, matse majors really do more chemistry than chemies, who are more process related. So came into Penn State majoring in material science and engineering. Back when I was in school, you had to pick an option. So my option was metal science and engineering, particularly from my background being a steel town. I interned at the Brackenridge Works before my junior year. My grandfather and two of my uncles worked there over the years, and actually worked in the finishing department where my two uncles were assigned, which was great back in the day because, they put out the word that the young woman that was on the floor was their niece. And, I was expected to be treated well out there. So as I go through my career, you'll see that I've always been based in the Pittsburgh area, but currently split my time between Nashville and Pittsburgh, spend about 85, 90% of my time in Nashville. My husband, his job is here. He's in data analytics at Vanderbilt University Medical Center. And the rest of our time, our home base in Pittsburgh, in Pennsylvania, is Pittsburgh, due to my family being all in Pittsburgh, still working for Westinghouse, which is based in Pittsburgh. And he's originally from Philly, so it gives us a home base up there. We are a very split family when it comes to professional sports. I am definitely a Steelers, Pens, Pirates fan, and he is very much an Eagles Flyers, oh God, I'm losing Phillies and 76ers fans. So, you know, I give a big thumbs down to the Philadelphia teams. But going from my hometown, kind of talking about my career, I often tell people when you look at my career, when you start from my major to where I got now, it doesn't really make sense if you look at it laid out on a resume. I really need to tell the story. But as I was prepping for this talk, it was the first time that really what I realized was I really have a career in problem solving and learning. You know, I like to be solving problems and I like to be learning all of the time. So, you know, it really started at Penn State in material science and engineering. You know, it was really that foundation. Like I said, I loved math, science, chemistry, really loved solving problems. When I graduated in 2000, it was the height of the dot-com boom. I had done internships at, as I said, at Allegheny Technologies. I also did an internship at Alcoa's Technical Center, did research on production of magnesium at atmospheric pressures. It had always been done under a vacuum. So did the thermodynamic analysis for that. It ultimately became my honors thesis, working with Dr. Liu. I saw that he's also attending, so it's great. Hi, Dr. Liu. I was one of his first 2 undergrad students that worked, did our thesis. I was his first honors student. He was my thesis advisor. But at my time at Penn State, I also majored in economics. I knew at that point that I also had a love for business. And I loved economics because it was truly based on calculus. So again, the math aspect. So graduating from Penn State, I realized I didn't want to be on the floor of a steel mill. I didn't want to be on the floor of a smelter. I found them incredibly interesting when I did go out, but it just wasn't what I wanted to do day to day. But what I did want to do was solve problems. So I went to Deloitte Consulting as a management consultant. I spent 4 years there. My last 2 years were spent as a test lead. So what the division that I was in, we did large scale custom IT implementations. And so my last 2 years as a test lead, you know, it kind of goes back to that problem solving. What we were doing is we were writing the test scripts for the system, my testers, and then testing it. You know, was the hypothesis, or, you know, liken it to a hypothesis, you know, was the system doing what it was intended to do, what the test we were carrying out? And if it wasn't, we would research why. We would work with the developers to find that solution and put that in place and retest until we got the results that we were looking for. During my 4 years there, I realized that I really wasn't going to go back to the pure technical engineering. So I decided that I needed to, you know, learn some more about business, and went to the Tepper School of Business at Carnegie Mellon full-time, quit my job. And while I was there, I found out that I liked accounting. I thought I loved accounting. I don't like it as much as I thought, but at the time, and I thought internal audit, internal auditors do accounting, or at least that was my assumption. So I went and I took an internship with Pfizer, and you'll start to see a theme as I go through. And part of the reason I chose Pfizer was, one, there was the internal audit internship that I was looking for. But, you know, Pfizer, being a pharmaceutical company, was really rooted in the science. And when I was in my interview and they asked me, you know, why Pfizer? And, you know, lots of people would be like, well, it's the best, you know, pharmaceutical company in the world. And it's true, it was, and it still is. But, you know, my answer to that question was, well, I really love math and science, and, you know, coming here will allow me to combine my business background along with my love of science with problem solving. And that's why I want to come. And later, this is one of the pieces of advice that I give people: be authentic in your answers to your questions in your interviews, because the recruiter at the time later told me after I was in the internship that part of the reason I got the job was because they felt my answer was really authentic. Like when I said, you know, my love of science is why I want to come here, they were like, okay, that's an answer that they don't often hear. Got to Pfizer, learned that internal audit is not anything related to accounting and, you know, bean counters and that stereotypical vision that you have of an auditor. Really what it is looking at the company's processes. Sometimes they're financial, sometimes they're operational, they can be compliance processes, but really looking at the processes, understanding are the controls there in place so that at the end of the process, you get the intended result that you were looking for. We're also looking at the processes. Are they the most efficient that there can be? Can you redesign the process to make it more efficient, make it more cost effective? So that's when I found out that I really did like internal audit. And oh, by the way, it was going to let me travel the world. The company was going to pay me to travel all over the world, learn all about their different businesses, and you get to see all these great places and cultures. And Pfizer really sold me. I got to spend 2 weeks at a facility in Singapore, got to spend a middle weekend in Bali, and I was hooked from there. Came back to Tepper for my last year and then looked for a full-time job. And I thought, what better place? Pittsburgh, Alcoa. I interned there as a metallurgist back in the day. And now I would be able to combine both of my degrees into a position. Went into Alcoa, did internal audit. Again, got to do exactly what I wanted, you know, look at processes, you know, help people identify where they can get better. I got to travel the world. I got to go to Brazil and Norway and France and Germany. And it was great. And I loved it. But I was also there at the time of the, you know, Great Recession of 2008, 2009. And they were going through layoffs. And I thought, I'm a metallurgist with an MBA, you know, Alcoa would never lay me off. And found out, lo and behold, yes, they do lay off people that have a metallurgy degree and an MBA. I say that this is really one of those career defining moments. I think it was actually the best thing that could have ever happened to my career, looking back. At that time, I had about a 2 to 4 month notice of the layoff. I found a position at Westinghouse and was pretty seamless. Got a 2-week vacation between the two companies and went to Westinghouse. What the other piece at Alcoa I had learned in addition to audit was I had a love of risk. And so I went to Westinghouse to start their enterprise risk management program. They came in and said, you know, you have 4 white walls, you need to build a risk program to look at our biggest and worst risks that we have as a company and help us identify what mitigations we need to put in. So I spent 4 years building that program and managing it before I moved to our new plant business development group. And there I was a commercial director overseeing a team that worked on the sales for our AP1000 plant, which is state of the art nuclear, large scale nuclear power plant. Basically putting bids together. So my teams were in charge of pulling all the cost estimates together, the pricing strategy, and all of the financing packages that would go along with the bid. I applied for a $10 billion loan on behalf of one of our customers with the Export-Import Bank of the United States. I joked at the time, I have no loans. I didn't have any student loans. I paid off my car loan. I was renting. And I was applying for a $10 billion loan on behalf of our customer. That was really exciting. but a colleague that I worked with, Alcoa, who had come to Westinghouse, recruited me to the compliance department. And he's like, okay, I need you to build a compliance program. We don't have an ethics and compliance program that we need. He's like, go figure it out. You have 4 white walls, build whatever you need. He's like, the engineer in you loves to build and figure things out. So that was the problem there, build out. I knew nothing about compliance, had to learn it all, everything from import, export, sanctions. I'm sure you all hear about sanctions in the news now. I can tell you a lot about that, and anti-bribery and corruption. I did that for a little over 2 years. I was still building and had a lot to go. And that same colleague that recruited me to compliance was now the CFO of the company. And he said, we need an internal audit department. Our internal audit department is not what the company needs. I need you to build one for the future. He said 4 white walls. He had known me since our time at Alcoa. He knew which buttons to push. He knew what I liked to do about the problem solving, the building, continuing to learn new things. And so that's what I've been doing for the last 2.5 years. I've gotten enterprise risk management back, my baby to start at Westinghouse, and has been rebuilding that in conjunction with building out our internal audit group. So it's really been a career of problem solving, building, learning. I get bored very easily, but it's I've really enjoyed my career and all of the various pieces that I've done in it. And then the last is Erica asked for favorite memories from Penn State. So I did then and now. Then hanging out with my classmates, my matse classmates, we spent a lot of time together working late on, homework and everything. But as you can see from these pictures, we also enjoyed going out, mainly to the Sports Center Cafe, which is now some noodles place, and so disappointing. But you see us here celebrating our upcoming graduation with Dr. Koss. He took us out. I didn't put the picture with us all raising our shot glasses because probably not appropriate, but also seeing us at graduation. And then now I met my husband through alumni volunteering. We both sit on the external advisory board for the Schreier Honors College. So we met doing that. It's a picture from our civil ceremony last May. We're one of those pandemic couples that are on our 4th wedding date. We have our big church ceremony and reception on May 7th of this year to celebrate our 1-year anniversary. And picture of us, we like to also get back to some football games. So we were up at the Indiana game this past October. So with that, if there's any questions.
Great, thank you so much. And yes, if you have a question, you can type it into the chat or Q&A or raise your hand and we'll call on you to unmute like Heather mentioned in the chat. Okay, so we have a question from Dr. Liu. So he said, great to see you. Congratulations on an exciting journey. Great presentation, and life is about solving problems. What about Ricky Stevenson?
Ricky, yes. So Ricky was the other undergrad that was in his lab when we were there. So she's right here with the red hair. Yeah, I'm friends with her on Facebook. She married her college sweetheart. So she's Ricky Fingal now, and she has 2 kids. So raising them, but yeah, so we keep in touch periodically through Facebook.
Great, thank you. There's another question in chat. Did you get the $10 billion loan?
We're still working on it. We did the Export-Import Bank said that they would loan if we completed the sale. So we're working with India, our customer in India on that. But yes, I got good at applying for very large loans.
Great. I had a question about, so you mentioned that you are on the external advisory board of the Schreier Honors College. What sort of activities does that entail?
So twice a year, we come up to campus, and we've been virtual for the last 2 years. So be there in April. And so it's a lot, it's not just alumni. There's a large group of alumni who are on the board, along with other business leaders. And we advise the college on where they need to go in the future and things like that. I am actually, they've just put new committees in place, and I am the committee chair for the Career Immersion Committee. So working with the college to design experiences for the honor students, so that they can learn more about specific careers, whether it be consulting or in healthcare, or technology. So working with companies to put together days where the students can travel to the companies and learn more about what you can do there and what you can do with your degrees. And in the future, once travel starts getting back to normal, I mean, we're also hoping to do this, maybe some trips overseas to different countries and have alumni travel with the students, and so that it can be a learning experience. So things like that.
Yeah, that sounds awesome. Very impactful too. Okay, great. So do you have an opinion on the viability of the various small nuclear reactors that are being proposed? And is Westinghouse working on these?
Yes, we're working, Westinghouse is working on them. We have our eVinci microreactor, which is, that is really going to target communities that rely on diesel. Also could be used in military applications, so forward bases that do not have connectivity to the grid. Obviously, I'm biased. I think our eVinci design is going to be very successful. We're also working on small modular reactors, a smaller version of our AP1000 that's in about the 250 megawatt, size. But yeah, I think eventually that will be the future. I think as we go off coal, move off of coal, we still need the large plants like the AP1000 to serve as base load, but really these small modular reactors and microreactors will serve communities and applications such as military applications, to serve them for their needs that they don't have right now and give them a clean energy source.
Well, I don't see any other questions in the chat or Q&A, so I want to take this opportunity to thank both Erica and Melissa for your presentations and time today. We really enjoyed hearing from our alumni, and we really appreciate your time and presentations, as I mentioned, and thanks to our audience as well. And our next Steidle Café will be April 28th at 10 a.m. Eastern, and hope to see you all there. Thanks so much.